Create a 3D design. In this video, we'll explore generative outcomes and we'll create a 3D design. In Fusion 360, let's carry on with our performance and weight reduction design. At this point, the generative has completed, so let's go ahead and explore the results. Once our Explorer interface opens, we're presented with all of the options that meet our criteria. You can see that we're automatically presented with some recommended outcomes, and you'll notice that one of these immediately has a problem. Because the obstacles we created didn't go around the back of the axle blocks, it was able to build in that area. That doesn't mean that we need to completely discount this as an option, but it does mean that we need to do some additional post-processing. Before we take a look at the recommended outcomes, let's take a look at some of our filters. First, we only have a single study, so we don't need to worry about identifying only a single study in a group of studies. But we can immediately discount completed versus converged results if we wish. We can also take a look at visual similarities. If there are multiple groups that have similarities, we can either isolate them to identify what those similarities are, or we can exclude them. We can also identify ones that are created using Tech Preview. These can be seen with the small icon in the upper right-hand corner. This could either be a preview functionality, in this case like casting, or it could be using the additional outcome solvers. Next, we can pick our manufacturing methods, our materials, or we can use some of our objective ranges. For example, if the mass is really important to us, we can identify specific outcomes that are below, in this case, 13 kilograms. This immediately filters out all of the options that are above that range. We can also bring that back and we can look at other things such as factor of safety. 0.13 is obviously too low, but if we bring this up to our factor of safety of about 2, we can see which outcomes we have left. At this point, let's go ahead and take a look at the 4 recommended outcomes and see if any of these meet our criteria. First, you'll note that visually, they are all very different. If we view them from the right-hand side, we can see the one on the upper right, outcome 4, which is a casting in the y plus y minus, is very different from the other options. If we rotate this around to a top view, we can see that we actually have a small section here with a truss-like design in it. If we zoom in, we can rotate this around and we can see that's actually a pretty unique design element. Let's go ahead and take a look at the shock and the suspension mount area. While we did create obstacles to ensure that we could get our tools to these areas, the way in which we designed those obstacles meant that it was able to build from the bottom. Now, obviously, this is not ideal, and if we show our geometry and rotate this around, you can see that some of the outcomes are building through the opening in that shock linkage. This is obviously a problem that we're going to have to deal with, and likely in post-processing, we would want to relocate these to the top section of that mount. So that's obviously going to take some work and should be a consideration that we're thinking about when we pick one of these designs. From the looks of them, I don't really want to use casting outcome 4, and I don't really like casting outcome 5 either. So this leaves me with outcome 1 and outcome 2. Both are very similar in nature, and if we take a look at outcome 2, this is unrestricted 5-axis milling, and when we take a look at outcome 1, this is unrestricted, and you'll notice that the manufacturing method does not include 5-axis. This is because it was a purely unrestricted method, meaning it didn't have to meet any manufacturing criteria. When we take a look at both of these from the right, we can see that the height of outcome 1 is a little bit less than the height of outcome 2. And also note that the truss shape is very similar in nature, but obviously outcome 1 has a little bit smaller profile. Because of this, I'm going to choose outcome 1 as my final design. And in order to bring this to our design workspace, we need to either create a mesh from it or we need to create a design from it. In most cases, you're going to want to create a design from the outcome as opposed to a mesh. We do have mesh manipulation tools in Fusion 360, which we can use to smooth or remesh a design. But if your end goal is to add more parametric features, such as opening back up the axle blocks or making adjustments to some of the other geometry, then you want to make sure that you use the design option, as that'll give you a T-spline body, as well as bring all of our obstacles and preserves in as B reps. So at this point, we're going to wait until we have our design that's ready, and we're going to go ahead and review that in the design workspace. Now that we have a result, let's go ahead and click to continue to open the design in Fusion 360. You'll notice that the orientation of the part is not how we intended in the generative study. And that's because Fusion 360 has options to model with Z up or Y up. In this case, this is just fine, and if we insert it back into the original design, everything will work fine. If you opted to solve your own generative study, then go ahead and solve the design now. If not, you can go ahead and open the supplied gen swingarm.f3d. Once you have the gen swingarm design, you can explore the design by going into the organic T-spline feature and make some adjustments if you wish. For our purposes, however, we're going to go back to our performance and weight reduction design. We're going to finish Explore and go back to the design workspace. This will bring us back to the entire motorcycle. Then we can expand the data panel and we can take the gen swing arm and simply drag it into our performance and weight reduction design. Because this was created in a Y up orientation, the orientation of the swing arm should be fine as is, and we can simply OK the location. Now you can see that we've placed the swing arm in the design, and of course there are some adjustments that we need to make. Things like adding back the details of the axle blocks and making adjustments so that it can clear the various portions of our suspension geometry. However, we do have plenty of room for the shock and some of the rest of the geometry, so we just need to make some changes here and likely connect them up to the top of that block. Everything looks pretty good, so I'm going to go back to a home view and make sure that I do save this design before moving on.